Hello guys, and welcome to the second video on curve fitting. Now, this is the second video on curve fitting. In case you are just coming to my channel for the first time, in the last video we treated solutions to writing different expressions. Okay, we treated this one. How do you form a straight line out of the following different equations? So if you want to learn how to do this, please watch the video just before this one on the playlist. Okay, so in this video we are focusing on method of least squares as I promised, and we're going to dive into the solution of this problem immediately. Now apply the method of least squares to fit a straight line relationship for the following points. So we're given points x and y. Basically what we just want to do is we are not plotting any graph. Okay, you're not expected to plot a graph in this question. You're just assuming that if I'm going to plot a graph out of these values, then I need to get a particular straight line. I want to find a straight line that will best model this data. So this is called mathematical modeling. When you want to this is just a small version of mathematical model. You just want to find the best relationship that will describe this given data, okay, that we have here. So we are going to use method of least squares to achieve that. If your hands are not too busy, get your writing material, get your scientific calculator, because you're going to need it in the exam hall. And I'm going to be fast while solving this because I've already solved it somewhere, okay, just for speed. All right, so let's go. All right, so these are data solution. Okay, so the method of least squares. So the method of least squares using the method of least squares, we're able to discover that anytime we are given n points of data, this is 1, 2, 3, 4, 5, so n is equal to 5 in this case. Anytime we are given n points of data, we can get a system of simultaneous equation that is given to us by this summation y, that's the sum of all y points, is equal to a summation x, okay, and plus n times b. Okay, so you'll be wondering where y, a, and b is coming from. Now what you're going to do is let the best line, or let's call it let the regression line. The regression line is also called the line of best fit, okay, or the straight line that you want to insert. So the regression line generally is taken as y is equal to ax plus b. Okay, so we want to find this equation. Basically, you want to find these coefficients a and b that will best fit this situation. Okay, the old way of doing it is to plot these values on the x on a graph, then use your hand and determine the slope locally and determine the intercept. I mean, that could be almost accurate, but using the method of least squares, you will find a more accurate depiction of this value a and this value b. So okay, so get this very well. Now in your solution, you make this statement first. Okay, so let the regression line be y equal to ax plus b. So using the method of least squares, we'll get this set of simultaneous equation. Okay, this is equation 2 because this is equation 1. Okay, then you will get another equation like this. Summation xy is equal to a summation x squared, okay, plus b summation x. Okay, so maybe in another video I'll show you how these equations were obtained, but not now. Okay, so this is the system of simultaneous equation we want to solve. We want to solve this simultaneous equation finding the values of a and b, okay, eventually, because summation y will be known. You can get summation y by adding everything about y here. Is that okay? Summation x will be known. You can get summation x by adding everything about x. Now summation x squared, you need to create an additional column and label it x squared. The same thing, summation xy, you create an additional column and label it xy so that you can be able to multiply x and y and add the values. So in that case, we have to create columns. The columns are x, y, x, y, and x squared. Okay, so you have x, you have y, you have x, y, and x squared. Okay, so this is okay, I think I missed this one. This is b. Okay, I think it's correct. It's correct. B summation x. Okay, like this. So you have xy, xy, and x squared. Okay, just these columns we created. Now, there is no need of you solving this simultaneous equation all over again when it has already been solved. Now, it has already been solved means that they have already solved this equation for you. All you just need to do is maybe to solve it by yourself or to memorize it. So for persons like me who solved it by myself, I was able to memorize it easily. Okay, so and because I solved it by myself. So if I solve this simultaneous equation, the value that I will get for A is n summation x y minus summation x summation y divided by n summation x squared minus summation x all squared. Okay, so if you can memorize this, memorize it by yourself. But if you want to solve this simultaneous equation by yourself, which I'm probably not going to do now, but in another video later in the future, I'll do it and show you how you arrived at this value for A. So the coefficient A can be gotten by these values. N is the number of data points, which in this case is 5. Summation xy is the sum of the product of all x and y's points. Summation x and summation y, the product will be okay. You just add all the x values and add all the y values and multiply them together. Then summation x squared is the sum of all x squared values, and summation x all squared is just this guy and you're squaring it. Is that okay? Now if you want to get b, the formula for b is a little bit crazier to memorize, but with time you'll get it. It doesn't have n. B is just summation x squared times summation y, then minus summation x y times summation x, like this, all over n summation x squared minus summation x all squared. Okay, so this is the formula for solving A and B. Okay, so now that I've laid the background, this is how you will solve it. First of all, you draw the table, then you say let the regression line be y equal to a x plus b. Then you now make all these statements. You can even go as far as making this formula. So I can put this in equation 4 and I can put this in equation 5. So the next thing I'm going to do is I'm now going to plot my tables. So I'm going to draw my tables like this. Okay, so for this table, what I just need is I need x. Oh, sorry about that. I need x, I need y, I need xy, and I need x squared. So the values for x, I'll just write them fast. You have negative 2.4, negative 0.8, you have 0.3, you have 1.9, and you now have 3.2. Now the values for y is minus 5, you have minus 1.5, you have 2.5, you have 6.4, and you have 11. Is that okay? So those are the values that you have. All right, so your xy is the product of x and y values. So if you have a calculator, you can verify it along with me. Okay, but since I've solved it in a rough sheet because of time, just verify how accurate it is. So this times this will give you 12, this times this will give you 1.2, this is 0.75, this is 12.16, and this is going to give you a 35.2. Now if you do x squared, you get 5.76 for negative 2.4 squared, you get a 0.64 for negative 0.8 squared, 0.09 for the 0.3 squared. So a 1.9 gives you a 3.61, and a 3.2 gives you a 10.24. Is that okay? So we have gotten all of these values. All we just need to do is to square them, or to sum them up. So I'll write sigma here. So sigma for this first one, so for adding up x, add all this one, you add them downwards, and when you add them correctly you should get 2.2. You add all these y values, -5 plus minus 1.5 plus 2.5 plus 6.4 plus 11, then you should get 13.4. Then if you add the xy values, you should get, I think, the biggest number of all of them, which is a 61.31. And if you add all the x square values, you get 20.34. Now, having gotten it like this, all you just need to do is to insert the corresponding values into the formula. Like so, from equation 4, I can get my a as, okay, a is n summation xy minus summation x summation y divided by, you have as n summation x squared minus summation x all squared. So this is how I can get a, which is going to be the supposed slope of the line, and we are dealing with 5 points. We're given 5 points. Okay, so you have 1 2 3 4 5. Now 1 2 3 4 5, so 5 in my summation xy. So you can see summation xy is 61 points. Okay, so this is, let me just write it, summation x, this is summation y, this is summation xy, and this is summation x squared. Okay, so I can make reference to it. So where's my pen? Something's behaving. All right, good. So my n is 5, summation xy is 61.31, then minus summation x, summation y. Summation x is 2.2, and summation y is 13.4. Then everything divided by n, which is another 5. And you now have summation x squared. Summation x squared is the sum of all the squared values of x, which is 20.34, and minus summation x all squared. Remember, summation x is 2.2, so 2.2 all squared. Now, if you have a calculator and you punch this very carefully, let's do it together. I think I can pop up my scientific calculator over here. So I'll open the fraction operator. So I'll impute this in 5 times 61.31. So 5 times 61.31 minus 2.2 times 13.4, then everything divided by 5 times 20.34 minus 2.2 to the power of 2. This gives me 2.86052. Okay, 2.86052. That's the value of A. So let's solve for the value of B. So for the value of B, remember the formula. The formula says B is summation x squared summation y minus summation xy summation x, and divided by the same denominator that we have here, n summation x squared minus summation x all squared. So my summation x squared, if you look above, you have 20.34. Then your summation y is a 13.4 minus your summation xy is the heaviest, which is 61.31, and summation x is going to give you 2.2 divided by the same denominator, which was 5 into 20.34 minus 2.2 all squared, like this. Okay, so we are just going to compute the value of this one with our calculator. We'll just adjust what the numerator should be, 20.34. Okay, so I'm adjusting the numerator, 20.34, right, times 13.4 minus 61.31 times 2.2, 61.31 times 2.2. So you get 1.421371. So I hope I keyed it in properly. Okay, yes, I think I did. 1.4213, 421371. Okay, so if we have it like this, then we can now see that therefore the regression line or line of best fit is y is equal to the value of our a. I'll just wrap it up to two decimal places, 2.86x plus my intercept is approximately 1.42. Is that okay? So this is it. So this is it about regression line. So this is the linear regression. There are different kinds of regression. Linear regression is about finding the slope and the intercept from a particular set of data given to you, two sets of data. So you train your model to give you the slope and the intercept, and the regression model is built on the power of method of least squares. Okay, as you can see above. So just try to memorize these formulas and it will make your life a lot more easier. So having said that, that's all about curve fitting and curve sketching. So I hope I might be able to solve one or two more questions. I've solved a lot of past questions. So just explore my playlist. Okay, look at my engineering mathematics engine 307 playlist and subscribe to this channel. Please hit the like button so that you can promote my video and other students like you will benefit from it. Thank you for watching and see you next time.